All right, nice to meet everybody. I am Austin. I'm on the product team at Offchain Labs, which are the creators of Arbitrum. Today I'm going to be talking about one of our upcoming upgrades, which we are quite excited about, called Stylus. And what Stylus does is introduce a new concept we're calling EVM+. So just to start us out, what is Stylus? So Stylus is a new way to write smart contracts in popular programming languages. There's two main components. One is a WebAssembly-based virtual machine that does not replace the EVM, but runs alongside it. And two, you have a canonical SDK that defines the patterns and frameworks that developers can write smart contracts in. So with Stylus, you have an additional execution environment with the WebAssembly-based virtual machine. And then you have a new programming environment that defines the way developers can write smart contracts. So I mentioned EVM Plus in the beginning, but let's dive into what that actually means. On the left, we have what is typically viewed as the EVM. People write smart contracts in Solidity. That Solidity gets compiled down into EVM bytecode, which then gets posted or deployed on-chain as a smart contract. With Stylus, we call this paradigm EVM+, because the EVM and Solidity-based smart contracts behave exactly the same as they did before Stylus. It's completely additive. So as you can see on the right side here, you still have the same flow I just mentioned with Solidity and EVM bytecode in the EVM. But now you have the addition of these other popular programming languages. With the WebAssembly-based VM, which I'll start calling WASM for short, any programming language that can compile down to WASM is compatible with Stylus. Some languages compile down to WASM better than others. So at first, we're primarily enabling Rust and C and C++. So in Stylus, the way this works is that these programming languages, such as Rust, get compiled down into WASM, and that WASM then gets compiled down an additional time to your machine's native assembly code. That native assembly code is then run in the WASM virtual machine and instrumented to make sure that that program is safe for the chain to execute before getting posted on chain as a smart contract. And the greatest thing about Stylus is that a developer building an app never has to worry about what language that smart contract was originally written in. Everything is fully interoperable and composable. A Rust-based smart contract can make a call to a Solidity-based smart contract and vice versa. So this is EVM+, and Stylus introduces it. So Arbitrum, and specifically Arbitrum 1, the flagship rollup that we all know and love, will get Stylus. This is a common misconception with Stylus, is that people believe that Stylus is like some new type of chain, or that is only going to be compatible with like new chains or new orbit chains, but that's actually false. Stylus is an upgrade to existing chains as well. Everything is fully compatible. And this is really powerful because Rust developers, C developers, all these new developers can tap into the existing liquidity and ecosystem on top of Arbitrum already. Whereas a lot of these other newer execution environments that we see today that are also exciting have to bootstrap this liquidity and ecosystem from nothing. So how is Stylus possible? Stylus is possible because of how Arbitrum Nitro, which is the core node software, already works and has been working for over a year. The way Arbitrum Nitro's fraud-proving technology works is when there is a dispute between validators, these validators, the execution history of the chain gets replayed in WASM. Validators will then bisect what is being disputed until they can deterministically prove who is telling the truth. And so, since the introduction of Arbitrum Nitro, which has been live for over a year, Arbitrum chains have been fraud-proving in WASM. And so, if we can prove over arbitrary WASM, that means we can tell the correctness of any program that is written or compiled down to WebAssembly. If we can arbitrarily prove WASM, that is what enables Stylus, because any program deployed by a developer now can be proven over using that same technology that we've been using for over a year. And so Stylus is really not some completely new rewrite of Arbitrum. It's a natural extension of Arbitrum Nitro and its fraud-proving technology. So, talking a little bit more about why Stylus matters. I've spoken a bit about the kind of accessibility with new languages and the composability with the EVM. But I actually haven't gotten into one of the most important aspects of Stylus, which is the efficiency improvements. The Stylus runtime can execute native assembly code much faster than Geth, which is the sort of execution environment in the EVM, can execute EVM bytecode. That speed of execution translates into massive gas savings. So when it comes to computation and memory, Stylus blows the EVM out of the water. For computation, Stylus can be over 10 times more gas efficient than Solidity in the EVM. When it comes to memory, and specifically using your device's RAM, this is typically infeasible in the EVM, but in Stylus, it's completely practical to actually use your device's RAM. And so in Stylus, memory can be upwards of 500 times cheaper than the EVM. It's important to note with this that there's a few different verticals of where gas savings come from. There's computation, there's memory, there's also storage. Storage, which is essentially like a transactions call data that gets posted to L1 Ethereum. This is roughly the same between Stylus contracts and Solidity-based contracts, because that data needs to get posted to Ethereum either way, and the compression algorithm is exactly the same. So what we'll see is that for functions that really don't have much computation or memory usage, you're not really saving too much using Stylus. Sure, you can still write the contracts in other languages, but the efficiency gains aren't there. So Stylus really comes in handy when you're writing a computationally intense or memory intense application. And so what Stylus is really about is enabling new use cases that were not previously practical in the EVM. So I'm going to run through just a few of the value propositions about Stylus, a few that I've touched on but can expand on a little bit. First is just one chain, many languages. Previously, you had to learn Solidity or some other kind of niche languages like Viper to kind of tap into the EVM and the liquidity, network effects, and ecosystem of the EVM. With Stylus, that it completely expands to a whole new world of developers. There's estimated to be around 20K Solidity developers, but there's estimated to be around 3 million Rust developers and 20 million C developers. And so at Arbitrum, we really believe that onboarding the next billion users will require onboarding the next million developers. Next is EVM plus. So one of the great things about Stylus is that the EVM acts the exact same way as it did before Stylus. Stylus is completely additive. It does not change anything about how the EVM works. And so as an EVM developer, you never even have to think that about Stylus or that it exists unless you want to use it. If you don't want to use Stylus, your experience stays exactly the same. We are not compromising on our EVM equivalence, and we really believe that EVM equivalence is no longer the ceiling, but now it's the floor. Advanced cryptography made possible. So I mentioned before that Stylus makes computation and memory of these smart contracts completely just overhauled in terms of gas savings. Computation is over 10 times cheaper, memory is over 100 times cheaper. So there's many use cases that just were not possible previously that now are. Next is safer by design. So an example of this is reentrancy, which is a common vulnerability in Solidity smart contracts, and something that developers can really only hope to mitigate. But in Stylus, we've designed the canonical SDK for this in mind. And so reentrancy detection in Stylus is extremely cheap. And in the canonical Rust SDK, reentrancy is disabled by default, unless you intentionally want to overwrite it. And then lastly, Stylus is fully interoperable. So with Stylus, there's not two siloed virtual machines. There are two virtual machines that run alongside each other. And these contracts, doesn't matter which virtual machine they are running in, are fully composable with each other. And so a Rust-based smart contract can make a call to a Solidity-based one, and vice versa. And this property does not exist anywhere else in crypto. So I mentioned a little bit about the efficiency improvements about Stylus, but I feel like it would be helpful to give some more concrete examples. When it comes to specific operations, the efficiency gains of Stylus almost seem silly. So if you break it down and get really granular, such as an add opcode, literally just a single operation, Stylus is 428 times more efficient than Solidity. We actually had to come up with a new way of measuring gas because of how efficient Stylus is for certain operations. So an add opcode in Solidity in the EVM costs 3 gas, but if Stylus is 428 times more efficient, it's going to be much less than 1 gas, and gas doesn't have fractions. And so we actually came up with a new measurement called ink. And ink is really only relevant inside of the Stylus runtime. It gets translated back into gas by the time it goes on chain. But it's just an example of how crazy efficient Stylus can be. When it comes to Ketchak, Stylus is 219 times more efficient than a Solidity counterpart. But again, those are just very specific operations. It's more helpful to see real world examples. And so credit to LimeChain for running these examples or benchmarks. Let's start with ERC20 functions. I mentioned earlier that computation and memory are much cheaper, but storage is the same. And so for functions like these ERC20 functions are mostly just changing storage slots, and there's really not much computation or memory happening. And Stylus contracts are a little bit more expensive to initialize and call for the first time. So we'll actually see that for these ERC20 functions, that these Stylus implementations are a little bit more expensive than the Solidity counterparts. This actually may change in a future upgrade where we're working on some caching optimizations, but for now, let's just assume that this is the case. And so Stylus may not make the most sense for these kind of simple implementations and operations. But then we come back to ED25519, which is really just a type of signature verification. And we'll see that Stylus is 81% cheaper, or 5 times cheaper than its Solidity counterpart. And while the contract verification is certainly computationally intense, like you can get more, you can do more. And really the more computation that the contract is doing, the more efficient Stylus will be. And so like use cases like this below, like alternate signature schemes, there's actually quite a few account abstraction wallets that are using different signature schemes. Like Stylus is an example of how you can save so much gas on these compared to Solidity implementations. So I guess just like to give some context on what can be built, just examples because it's really up to your imagination, and maybe a few real world examples of what's being built. So one is custom precompiles. Precompiles is in quotations because typically a precompile is like native to the chain. Whereas like precompiles and Stylus, they're really like pseudo precompiles where like, because it's so much more efficient, you can wrap these computationally intense operations and deploy them on chain in an efficient manner, which you know, kind of act as pseudo precompiles. And a clear example of this is a team called Renegade. Renegade is building a private exchange where the user's orders are kept private, which mitigates MEV and a whole host of like other advantages. The way they achieve this though, and I'm being succinct, but are through ZK proofs. And as we may know, verifying ZK proofs on chain is expensive. With Stylus, they're now feasible. And so Renegade is like, which was completely unfeasible anywhere else in the EVM. And actually in other execution environments was not feasible either. But now with Stylus, they, for the first time ever, like they're able to do this in a way that is practical. They're able to verify ZK proofs on an Arbitrum chain. They're able to verify ZK proofs on an optimistic roll. So Renegade is like a really cool project that I urge everyone to check out. Second is like complex generative art libraries. So these like generative libraries in Solidity are usually pretty constrained in terms of how much like memory and computation are involved. But with Stylus, like not only can you use more in computationally intense libraries, but you can pull existing ones from like Rust crates or existing C libraries. So it's not just about like the efficiency, but you can also just like plug into like all the existing libraries that just like are already there, that other people have written that may have nothing to do with crypto. Third is like existing game libraries in C++. There's so many games that are written in C++, and being able to bring these on chain is as easy as just deploying. This is just like some of the magic that Stylus enables, because we're not building a new programming language. We're just allowing developers to tap into that kind of existing developer ecosystem that has been around for decades. Fourth is like compute-heavy AI models. Like again, like computation is so cheap in Stylus that like leveraging these AI models is now feasible. There's this one team, I'm not sure if I'm able to share their name yet, but they're building sort of this on-chain sort of derivatives marketplace. And they have this automatic repositioning algorithm, and it's computationally intense, this algorithm, to kind of reposition a person's liquidity providing position. And so using Stylus, they're able to do this in a way that is cheap. And it really only like is relevant for Arbitrum 1, like for chains with a lot of liquidity. And as we may know, Arbitrum 1 is definitely the home of DeFi in terms of L2s. And so Stylus, Stylus DeFi, and really just like Arbitrum are a perfect match. So when mainnet, Stylus is currently like on a testnet right now. It's on a standalone testnet that it's public, anyone is free to use. If you need testnet ETH, come up to me after. But Stylus is undergoing an audit by Trail of Bits right now that's scheduled to complete around the end of March. At that point, and maybe shortly afterwards, Stylus will be labeled as production ready. After it's labeled production ready, Orbit chains, which are like the Arbitrum app chain ecosystem, will be able to enable Stylus on their chains almost immediately. For Arbitrum 1 and Arbitrum Nova, it will go through a governance proposal where the DAO will vote to either enable it or not. But yeah, so when mainnet, pretty soon. Definitely this year and most likely in the next few months. That's the end of my presentation. But yeah, thank you everybody. Yeah, sure. I think I'm out of time, but if anyone has any questions, I'm happy to answer. In the back, I don't know if I can hear you from here.
Justin, can you hear me?
Yeah.
Yeah, so with Stylus, do you have any plans on, is it possible to build everything on chain with Stylus? You mentioned building a game with C++. I found that very fascinating. Could, in theory, a developer build everything on chain, like front end, file storage, or is that something in your roadmap in the future where you could take away AWS, Google Cloud, and put everything on Stylus, on Arbitrum essentially? Is that something that's possible, you think?
So I guess it's going to depend on the use case, right? Even if Stylus makes certain applications cheaper, it's not free. And especially when it comes to storage, like when it comes to Arbitrum 1, which is a roll-up and post-transaction data to Ethereum, that's expensive. If you know, there's other ways to cut costs, but I think it really just changes the mindset of what you can do on chain. I don't think it necessarily means that it makes sense to put everything on chain. For some applications, it's going to make sense to verify ZK proofs on chain. For some applications, it's going to make, like for some games, it's going to make sense to have more of those in-game actions all on chain. But for many applications, it's, you know, I think we're seeing that like for the core parts of the protocol, such as like the account, like that needs to be on chain. But many of the other components of the application don't necessarily need to be. So I wouldn't think so much about like Stylus as replacing these kind of like off-chain components, but just like enables developers to bring more complexity on-chain.
Thank you.
Yeah, if anyone has any other questions, please.
How do you meter gas in Wasm? Is it like per opcode? Do you profile it on a system, or how do you go about it?
Yeah, so Stylus actually has its own pricing table. You can find in the docs actually how much like each opcode costs. And yeah, we've actually like through this exercise have discovered how mispriced the EVM is on certain operations. And it's funny because, you know, Stylus could deviate Arbitrum could actually go ahead and price the EVM more correctly to, you know, essentially the goal is to price things equivalent to how much resources they're taking up. The EVM is terribly mispriced in some cases, but if Arbitrum were to change the pricing of the EVM, we would then be breaking EVM compatibility with Ethereum. But yeah, if you're interested in like the pricing table for Stylus, I urge you to check out the docs. Cool. If there's not any questions, I'll probably end it there. Thanks, everyone.